Today we are reviewing lattice energy, and this will be the Hess's law approach to solving lattice energy problems. So, first, these are given energies and values, and we are looking for the standard heat of formation for strontium chloride. So, in equation form, this is what we are looking for. Now, the lattice energy, which is the energy needed to go from, to create 1 mole of a solid lattice from gaseous ions. So in equation form, that will be strontium with a positive 2 charge plus 2 chlorines with a negative charge going to strontium chloride in the solid state. And that's the lattice energy. So, now in order to get our ions, especially first starting out with strontium, into the ionic form, we need to look at our ionization energies. So the first ionization energy for strontium is strontium gas going to strontium gas with a positive 1 charge, and we're losing 1 electron because ionization energy is the energy needed to remove 1 electron from a gaseous atom. So, and then that's our 549 kilojoules per mole. Okay, our second ionization energy is the same concept. It's removing the 2nd electron from the strontium, but this time we're starting out with the strontium ion. So strontium gas, positive 1 charge, goes to strontium gas with a positive 2 charge, and we're losing 1 more electron. And this energy is 1,064 kilojoules per mole. Okay, now our heat of sublimation, which comes before our ionization energies, because we need to get our strontium solid into strontium gas. That is going from our strontium solid to strontium gas. That energy is 164.4 kilojoules per mole. Our dissociation energy of chlorine gas is, so at this point we're done with strontium. Now we need to look at chlorine. And first we need to get rid of the diatomic chlorine, and the only way to do that is to dissociate the bond, which means that the chlorine bond in the gas will break, forming 2 chlorine atoms. And our electron affinity for chlorine electron affinity is the energy required to add in or capture 1 electron for an atom. So chlorine, remember this is not diatomic, chlorine gas, and we're adding 1 electron in. So that becomes the chlorine ion in the gaseous state. And these energies are 243 kilojoules per mole and negative 349 kilojoules per mole, respectively. So, now that we have all of our steps written down in an equation form, now we need to look at how we need to alter these steps to make them fit our goal equation as with Hess's law. So, the first thing that we need to look at is that we do have our desired product right here. And now we need to find our two reactants in these equations. So we have strontium solid and we have chlorine gas here. So we have our chlorine right here. So now we need to look at what we can cancel out. And we have our strontium gas, which cancels out here and here. We have our chlorine gas, but instead, this one is only one chlorine gas, where here we're producing two chlorine gas. So we need to multiply this equation by 2. In turn, multiplying our value by 2. So here this will become 2 chlorine gas plus 2 electrons goes to 2 chlorine ions in the gaseous state. So all right, so now we can cancel out our 2 chlorine ions from our lattice energy up here. We can cancel out our strontium ion, 2 plus. We can cancel out our strontium 1 plus. Here our electrons cancel out. So both of those go to cancel out the 2 electrons. So now, and because this is still on the reactant side and these 2 chlorines are on the product side, those 2 cancel out. So we are left with, so this equation. So what we're left with is strontium solid plus chlorine gas goes to strontium chloride. And when we remember to double this value, when we add all these up, we end up with our answer for our standard heat of formation, which is negative 804.6 kilojoules per mole.